automation will reduce the need or the requirement or the interface of the uh, human labor. Okay, so rather it will do it automatically, so that product quality will not get affected. Getting it? Okay, so here also as such, if you check about the automation in case of the injection molding, most of the processes of injection molding are already automated. In the sense, injection molding itself is a uh, having a high level of automation in the original setup itself. Getting it? Okay, so process itself is designed in such a way that it is automated process. Okay, very less interaction with the human labor. Okay, so that's why we're not going to see a more level of automation, but just we are discussing basic systems which are there in the injection molding process. So out of that, we discussed about the temperature control system, whereby I told you that in the temperature control system, cooling mechanism is the most important rather than the heating mechanism. Okay, so cooling mechanism will ultimately decide the quality of the product or the strength or whatever the properties required that are decided by the cooling. Okay, so keep it in mind always. If you want the change in the microstructure of any material or the component, metallic, plastic, anything, okay, there is one basic process: heating the material up to the recrystallization temperature or above the recrystallization temperature, and then cooling it down. So heating will not matter. Only heating will matter up to heating will matter. Heating will matter in case of range of temperature. Getting it? Not the level of temperature. Level in the sense whether you are heating fast or slow. Okay, so I mean how much you are heating it up to 100 degrees Celsius, 200 degrees Celsius, that matters. But in case of cooling, cooling rate matters. Okay, heating rate doesn't matter, heating range matter. And in case of cooling, cooling rate matters. Okay, so cooling rate will decide the quality of the product or the uh, this microstructure of the product. Okay, so that's what we discussed in the temperature control system. Then we discussed about the ejection system, how to eject the product in case of injection mold. Different kinds of ejections mechanisms we have seen: air type, sleeve type, wall type, stripper type, pin type. Okay, then we discussed about this feed system. Okay, so feeding mechanism. And in that feeding mechanism also, I told you that feeding at the start is not important. Like here, you are feeding the material from the hooper, that is not important. Feeding from this point is important, from the nozzle point to the in the mold cavity. Okay, so that feeding is important rather than the previous feeding. Now this is the design part. Last one is the design part, design of a component. Before that, we'll have to see these types of injection mold: single or multi-cavity, two plate and three plate molds. Okay, so basically these are the type. Again, we discussed one more type also previously in temperature control: hot runner type and cool runner type. Okay, this is also one of the type, but that is we have already discussed. So currently we'll discuss now single, multi-cavity and two plate and three plate type mold. Okay, and then we'll go for the problems based on this. Okay, this is the setup of the injection molding: hooper, barrel, the red colored material is there. These are the heating coils. It will be heated in this section. This is the nozzle through which it is passed through the mold cavity. This is the mold setup. This entire is the mold setup. This is the ejection mechanism. Okay, and this is the cavity. This is the red colored cavity. Okay, getting it? So this is the simple mechanism of the injection mold. These are the ejection systems in the injection mold: pin type, sleeve type, wall type, air type, and stripper type. Okay, that also we discuss in detail. Right, so we'll not go again. Okay, feeding mechanism also we have seen. Feeding in the mold is important, and in that we discussed too many things. What kind of feeding mechanism should be there? Okay, so this is the feeding mechanism. Okay, sometimes you will have uh, sub runners, activity runners, branch runners, multiple runners. Okay, depends. Getting it? Okay, now if you can observe, now just take an example here only. This is the products. These are, sorry, these are the products: product 1, product 2, product 3, product 4. Okay, so what are you doing? at the time at a time you are manufacturing 4 number of products, or else if you remove this entire mechanism, you can connect directly sprue to the gate and you can manufacture only one product. See, this is the product. So you can manufacture only one product also. Provide here simple gate, okay, then a runner, and at the top this will be a sprue, okay. So with a single sprue you can go for the single product also, okay. So here in this case you need only single cavity. But now check out with this setup: one first product, second product, third product, fourth product. Obviously all the four products are same. So how many cavities will be required? Cavity 1, cavity 2, cavity 3, cavity 4. So this is called as multi-cavity. Simple definition, okay. With the setup only you can understand. And this is called as single cavity. So where you are manufacturing single product is a single cavity. Where you are manufacturing multiple products at a time, it is a type of multiple cavity type injection mold, okay. Obviously just this was an overview. We'll discuss this single cavity, multi cavity in detail, okay. Right now look at here. From this point we'll start types of mold, okay. So just I'll highlight the important point. In general, choice between single and multi cavity mold come down to time frame and demand. Very important word, okay. This is the only word I need to highlight from this para, okay. What is there? Time frame and demand, okay. Need not to recall entire para, just focus on these two words: time frame and demand, okay. What does it tell? See, either to go for single cavity or to go for n number of cavity, it depends entirely on this time frame and demand. Time frame is nothing but cycle time. Cycle time means what? You are putting the material inside the setup and you are getting the product. So time of entry of raw material to the time of dispatch of final product. This is called as the entire cycle time or the time frame. And next is the demand. Getting it, okay. So when product is very small, demand is very high. Understand? If product is very small and demand is very high, then there is no need to go for a single product manufacturing at a time. You can go for the multiple product manufacturing at a time, okay. That is called as a multi cavity. So if demand is more, increase the productivity. How to increase the productivity? Try to go for multiple manufacturing, I mean multiple product manufacturing at a time. That is a demand based. And if you want that productivity in less period of time, in a less cycle time, then you can go for the multi cavity, okay. Are you getting? Simple thing. So it is totally demand and time driven factor. If you need more number of product in a shortest time, go for the multiple cavity in the sense here you can manufacture multiple products at a time, okay. When many identical parts are needed within set time frame, multi cavity is preferred, okay. Nothing else such difficult, simple thing. More number of products in a shortest time. If you need it, go for the multi cavity, okay. Multi cavity means what? Simply so many openings will be there, and at a time the raw material is provided to all. Getting it, okay. So that's how multi cavity things will get, okay. So it is a clear advantage of using multiple cavity. What you will get? Manufacturing more number of products faster, okay, in a shortest possible time, right. Second, however, multi cavity molds are always not best fit, okay, aren't always best fit. Getting it, okay. Why? Now check out this one. I need 4 products at a time. So I will go for this kind of setup. This one, I need only 1 product at a time. I will go for this kind of setup. Simple. Getting it. Material will come from this and it will enter in this cavity. So just look at how simple this is. This is for a single cavity and this is for multi cavity. Check out. This is a totally a complicated structure. Complicated in the sense complex structure. Obviously, it will require more setup cost. And in case of single cavity, less setup cost. Getting it? Okay. So as far as cost is considered, a single cavity system will require less setup cost, but multiple cavity system is require more setup cost. Okay, so this is one agenda. Getting multi-cavity mold requires more substantial upfront investment. Upfront in the sense initial investment. Okay, rather than a single cavity mold. Okay, and see, multi-cavity require more material, more labor, energy resources than a single cavity mold. Okay, now see, this is the thing. What you want to draw out, setup cost. Setup cost is more. Setup cost is more in case of the multi-cavity. Getting it? Okay. Now, third factor, multi-cavity mold requires substantial lead time. Multi-cavity mold require substantial lead time. Okay, lead time means what? Lead time in the sense time required to fulfill the entire mold cavities. Simple thing, if you are having only one opening, easily in a short time you can fill it. You are having same kind of 4 to 5 openings, you may need a more time. Okay, lead time in the sense time required in advance before getting the products. Okay, so here lead time will be more. Apart from that, maintenance cost and risk is higher with multi-cavity mold. Obviously, more complex setups, more maintenance. Complex setups will yield to more maintenance. Okay, so these are some of the pros and cons. See here, a clear-cut definition is given. A single cavity mold produces single product per cycle. Single product per cycle, while multi-cavity mold produces more than one product per cycle. More than one product per cycle. Okay, so that's what here is required to highlight. Single cavity, single product per cycle, and multi-cavity, multiple product in a cycle. Okay, cavity means what? I should not discuss it, but just let me tell you. The sequence of events during the injection mold of plastic part is called as the injection molding cycle. Okay, so cycle time. Okay, two things I told you: time frame and demand. Time frame is nothing but the cycle time. The cycle begins when mold closes, followed by injection polymer into mold cavity, and once cavity is full, holding pressure maintained. Okay, so see, what is cavity in the molding? I think answer is quite different and question is different. Okay, just understand. See, this cavity means, because we are defining single cavity and multi cavity, cavity means these are the openings provided in the mold box. Okay, and the openings are nothing but the prototype of the product. These are the prototype of the product. Once you will pour the material inside this cavity, material will be allowed to solidify and it will give the exact replica of the final product. Okay, so these are the mold cavities. Okay, simple. Here you will understand easily. Check it now. Okay, split mold. Okay, these are not two products. If you can look at here carefully, this is a PET bottle. PET bottle. Okay, polyethylene tetraphthalate bottle. Okay, this is not bulge. This is a surge inside. Okay, so these are the two molds. You can close it. Here screws are provided. Getting it? Okay, and here the holes are there, right? So this is a single cavity type mold, because only once material will enter from this side, only one bottle is produced, and this is a kind of multiple cavity type. One product here, another product here, third product here, fourth product here. Getting it? Okay. So this is a central runner. These are the sub runners which are providing the material to the cavities. Okay, so this is called as a four cavity. As such, there is a no classification, two cavity, three cavity. Only classification is single cavity and multiple cavity, or the multi cavity. Okay, getting it? Okay. So this is a single cavity mold where at a time only one product is manufactured, and this is a multiple cavity mold. Okay. So pros and cons of multiple cavity mold. The desired number of, these are the pros. Desired number of products will be finished sooner because of the shorter lead time per batch. Okay. At a time you will get the products, so finishing will be also fast. You can produce more products with the same mold within a short span or the short guarantee. A four cavity mold has in most cases lower total cost of ownership than a four single cavity mold. Simple thing. Rather than having this is a one mold, one machine. Okay, here is a one machine, second machine for second product, third machine for third product, and fourth machine for fourth product. So if you are manufacturing the products by single cavity setup, so you need four machines to manufacture four products. But with multiple cavity setup, you can go for a centralized runner and simply sub runners. So one setup will satisfy everything. More efficient use of cycle time. Obviously, in a short time, in a decided time, defined time, you are getting more number of products. Major scale benefits for the special stable process and lower part price. Okay, what happens actually? Simple thing. In a particular amount of time, if you are producing 10 number of products, and in the same amount of time, if you are producing 20 number of products, so obviously this 20 number of products will have less cost, and this 10 number of products will have more cost, because cycle time is more and time is going to be cost in terms of the money. Okay, so simple, these are the parameters. Obviously stability balancing part will be good in case of the, this stability will be good in case of the multiple cavity. Okay, just only some things, some important issues with respect to this point. See, this is suppose central sprue. This is the one runner, second runner, third runner, fourth runner. Here is one product, here is another product, here is third product, here is fourth product. So in this case, this is a balanced setup. This is a balanced setup. So here stability will be good. But same multi-cavity setup, one product here, another product here, and third product is here. In this case, stability is going to be less. Are you getting? Simple. This is a mechanism. Sorry, this balancing part you may have studied in the theory of machine also. Okay, so here you will get a good balancing in the sense stability of the process, but here balancing will not be proper. So possibly try for the even number of products at a time. Disadvantage of multi-cavity. One multi-cavity mold requires more substantial investment. Okay, we discussed it. Initial setup cost is going to be more. Longer lead time for the mold manufacturing. Obviously, the complex setup, so lead time is going to be more. If there is any problem with one cavity, another one major issue, entire mold setup is taken out of the machine. Okay, so what is there? Suppose this is a multi-cavity, 1, 2, 3, 4. If suppose there is a problem with this cavity, so you cannot individually remove it. You will have to take out entire setup and you will have to hold the process. Getting it? Okay. You have to remove the entire setup and then separately you can go for the maintenance of this particular cavity. Okay. But you cannot go in such a way that you will remove this one and you will go on working with these three setups. Okay. No. Okay. Entire setup is taken out, replace the default defective mold, and then again restart the entire process. Okay, so that is the one issue when using automated process to operate mold with a large number of cavity. Each cavity will have to be absolutely perfect. Okay, Again, see this kind of problem we discussed in case of transfer molding also. More number of movable parts, it makes a hindrance to the automation. So here also it happens. See, when you are using only one cavity, the automation of this single cavity is a simple one, okay, because there is a fixed path. But if there are more number of cavity, okay, so this setup is required to manage perfectly, because any irregular movement of any one cavity, either this one or this one or this one or this one, will disturb entire setup. Okay, so automation will hamper in this case, because see, more number of setups are working at a time, so you will have to manage the time frame properly, you will have to set up the things properly. Here only one setup is under consideration, here four setups are under consideration at a time. Getting it? Okay, so this, in case of multi cavity, there should be absolutely perfect management for all the setups. Okay, then only this automation is possible in this case. In case of single cavity, very simple to go for the automation, because you have defined a route, and being only one cavity, it is going to follow the same route. Okay, next one. This is same type of classification, quite different one. Two plate mold and three plate mold. Okay, now this two plate and three plate category, you have studied it in a casting also in the manufacturing process. Okay, okay, rather than discussing this, I'll show you the figure, you will clearly understand, or just will see. Two plate mold or single parting surface. In case of two plate mold, there is a single parting line or single parting surface. Okay, simple to use, most widely used. Two parts are there, one is a moving half and another is a fixed half. Okay, now see the setup. Okay, check out here. Right, now forget about this one. See, this is a three plate mold setup and this is a two plate mold setup. Okay, this is a plate number one, plate number two, and this is a plate number one, plate number two, plate number three. Getting it? Okay, so this middle supporting plate is there, this middle supporting plate is there, right? And so this, there are two parting surfaces, one is at this location, another is at this location. So there are two parting lines or two parting surfaces. In case of two plate mold, there is only one parting surface. Getting it? Okay, obviously quite difficult to manage the three plate mold. Another one issue, if you check clearly, you will understand the difference between two plate mold and three plate mold. This setup, this runner setup, a local header runner, this is adjusted with middle one plate, and in case of two plate, it is directly getting attached on the product surface. Are you observing? This runner is getting attached with the product surface, but here it is not happening in case of three plate mold. So if you don't want any remark of runner on the product surface, here if you don't want any remark of the runner on the product surface, then you can go for the three plate mold. Or else, if you can adjust the mark of runner on the non-facing surface, non-facing in the sense, suppose this is the product, so this is the shining surface, front surface, so you can attach the runner from back side, okay, which is not a facing surface. So this can go for the two plate mold. Okay, so major issue is that this runner marks will be there on the surface of component, but here runner marks will not be there in case of surface of component. Okay, so that's what is given here. Core side is in the moving mold half and cavity side is in the fixed mold half. Same thing, this is a fixed half where cavity is there, and this is a moving half, moving half, moving half. After molding, the ejection molded product and runner remain in the moving mold half. Okay, here it is clearly given. After molding, ejection molded product and runner, okay, both are there, both are there. Getting it? Okay, and the movable mold half is equipped with the ejection system and push the products away from the opening mold. Okay, and here in case of 3, this structure, three plate mold, this structure is suitable for products which are not allowed to have gate marks, runner marks or gate marks on this side wall. Are you getting? Okay, if the product doesn't want any marks on the surface, then this three plate mold is preferred. Okay, which are the three parts? One is moving, at the top moving, at the bottom fixed, and at the middle one there is a stripper part, stripper plate. Okay, so this stripper plate will be there in the middle. This kind of mold has complicated structure. Three plate mold is divided into normal three plates mold and the simplified three plates mold. Look here, just see the setup carefully, you will understand everything. Right, getting it? Okay, so three plate mold, this is one, and these are the main plates, this one and this one. Okay, so this is called as a stripper plate, which will give the access for the runner, and the material will be passed through this point, so marks will not be there on this product. And in case of two plate mold, it is directly connected with this. Obviously the complicated setup will be there in case of three plate mold, it is not there in the two plate mold. Okay, and these are the ejection pins. These are the ejection base, and here is the ejection pin. One is here, another is here. Okay, so this central middle is the ejection pin. Okay, so I'll show it to you. Just a minute. Okay, so this is a multi cavity. Okay, this is a multi cavity setup. Are you getting? Okay, are you observing this many number of cavities? You see, here is the cavity, here, 3, 6, 9. 9 cavities are there, and 9 products are manufactured at a time. You can check out the cycle time, very fast cycle, very less cycle time. Okay, multi cavity, and this is a single cavity. This is also explained nicely. Single product, only one single product at a time. Check once again. Getting it? Okay, only one product is there. Okay, so see the cycle time, how much time is required for manufacturing one product. Okay, same kind of product you can go for the multi cavity also, here by providing multiple cavities you can go for the multi cavities also. But see, as per the need of the product, the setup is followed, only one. Right, and this one was for, I think we have seen this. Look here, here is also one single cavity setup. Process is different, one single cavity. Okay, only one. In case of blow molding, mostly only one cavity setup is preferred. Are you getting? Look here. Process is different, but same concept. See, single cavity type setup is there. Okay, same product, single cavity setup. But if you can go for the multi cavity setup for this kind of product, there is option. This is a single cavity. And this is called as a multi-cavity. Are you observing a different setup, totally different setup, but multi-cavity type? Are you getting? At a time you can get more number of product, right? Okay, so similar concept, multi-cavity type. So right. Okay, so and this cold runner and hot runner already we have seen in the last lecture only, and this is based on the cooling mechanism. This is based on the cooling mechanism. Getting it? Okay, so these are the, this is the classification for the injection mold. A 3-plate mold having 3 systems: moving plate, sorry, moving mold plate, fixed mold plate, and runner or stripper is the central plate. Okay, the purpose is that there should not be, sorry, when there is a requirement that product should not have any kind of marks, getting system marks on the surface of the product, then that time 3-plate mold is preferred. Okay, quality product you will get. And in case of 2-plate mold, a simple setup, initial setup cost is also less, and only 2 plates are there. One is the top one moving half and the bottom one fixed half. Mold cavity will be in the fixed half and the runner and screw arrangement will be in the moving half. Getting it? Okay, so obviously, but here the marks will be there on the surface, so you can have option for that also, which is a non facing surface. Getting it? Okay, which is a secondary surface, back surface. On that surface you can put up the gating system, so that it will not be shown on the top. And another one is a single cavity and multi cavity. Single cavity, easy to set up, no any skilled workforce is required. Initial setup cost will be there, lesser. Only thing is that productivity is going to be less. But if product is so large, one more point we missed. If product, see, size of product is also matters. If product size is so large, that time preferably you cannot go for the multi-cavity molding. Okay, because that time entire mold size is going to be very high. So when product size is very high, it is preferred to have a single cavity mold design. When product size is very small, then you can go for the multi-cavity injection mold design. Okay, so for example, caps of the plate bottle. Okay, plate bottle caps. So a simple small size product, nothing any precision or accuracy is required. So that you can go for the multi-cavity type product, right? So here also you can get the example. Now this is a single product, but if you want such a kind of product at a time, similar kind you can keep it from other side also. Same setup. See what kind of setup this is. One from this side, one from this side, and similarly another at the another end. Getting it? Okay, this way. And a central runner will provide the material to you both. Okay, so same product we can go for both the ways, single cavity type and multiple cavity type. Just we'll have to ensure that the size of the product. Getting it? Okay, see what is happening actually. when there are multiple cavities in the product. Material is coming through this central setup and then to the sub branches. Getting it? Okay. So this time feeding rate requirement will be more. And what happens? Material will slowly enter into cavity. Obviously, there will be an equal rate, but material will slowly enter in the and all the cavities. So there is one problem maybe happen. It will possible that because of the less input rate. See, if you are having only one cavity, material can be fed very fastly because you have to fill up only one cavity. Here you will have to fill up 4 cavities. So material will enter or material will enter into cavity slowly. Material is in heated condition. If material will enter slowly, it may possible that, see, this is the component. At the bottom, different cooling rate. Second level surface, different cooling rate. At the top, different cooling rate. Why it is happening? Because material is coming slowly. When material will come fastly, this entire cavity can be filled at a time, at once, and the uniform cooling rate you can obtain. But this is quite difficult in case of multi-cavity. So that when product size is small, prefer to go for the multi-cavity. When product size is large, prefer to go for the single cavity. Are you getting why I am telling that small size products are preferred with multi-cavity and large size products are preferred with the single cavity? Because of difference in cooling rates. Okay, in depth, if you will think, you will get this kind of answers, right? Okay, so this is what about the classification of the injection or the types of the injection mold. Right. Okay. So in your exam, if the question will be there for types of injection mold, so try to mention all the things at a time: single cavity, multi cavity, 2-plate, 3-plate, and hot runner type and cold runner type. Okay, because all these types are there for the types of injection mold. Okay. Right. So this is the type of multi cavity. Okay, then now we are done with the single cavity, multi cavity, 2-plate, 3-plate mold, feeding system or the feeding mechanism, temperature control system or the cooling mechanism, and the ejection system of 5 types of ejection system. Okay, so that's what there in the theory. Now we are having a next part as design procedure for injection mold of for simple component. Okay, so that we will discuss it in a next lecture. So maybe in the next lecture we will see the formulation and the one problem based on that. Getting it? Okay, so we'll for the today we'll stop here.